Okay, back at the wing again. So, as I said, I chose the wood construction over the aluminum for a couple of reasons. Number one, the aluminum, initially, once again, it's the whole setup. It takes quite a bit of setup to actually do it properly and skin it and everything. A little bit less involved with the setup for a wooden wing. The other big advantage of the wooden wing over the aluminum one is if you get some kind of damage on the aluminum wing, it's quite hard to repair damage on an aluminum wing. You have to kind of like pop it out somehow and then sand it all out and try to repair it. It's difficult. It's almost impossible to repair it so that it's back to its original state again. With a wooden wing, wood and foam and fiberglass, you get some kind of damage to the wing. It's much easier to patch it, put a little bit of fiberglass on it, some glazing putty, sand it all out, some primer and paint, and if you do a half decent job, it's virtually impossible to see that it had damage on it. It's repaired really nicely. So that's one of the reasons why I went with the wood wing. I built a lot of wood and foam and glass wings for model airplanes, RC planes, and they turned out really well. And this is basically a very similar method. It's a little heavier duty because in an RC plane, you know, you might reach 75 miles an hour in a dive. And this car, I'm expecting it to do probably 165, 170 in the quarter mile. And if I get more sponsors come on board and we want to step it up, there's no reason why this car couldn't do well over 200 miles an hour. So with that in mind, I beefed up the construction on the wing so it'll be able to, you know, take the downforce of air on the wing at those speeds. With most wings, the problem is not making it strong enough for air forces. The problem is making it strong enough and durable enough for handling. And so when you take the wing off and you set it someplace and it falls over or something falls on it or something like that. So they usually most likely get damaged in handling in some way. And so that's one of them, like I alluded to, one of the reasons why I've gone with the wood construction. It's just easier to repair. So how this works then is we've got the main spar here, and it's basically like an I-beam. It's got a top plate and a bottom plate and a vertical web. These are all epoxied together, and it's the main structural member of this wing. It carries most of the loading. These ribs will be epoxied to this main spar, and so the ribs are what holds the mounting plates like this, the aluminum mounting plates that you saw in the video. And the mounting plates, they'll be attached to these ribs. A little bit sticks out the bottom, so it'll be like that. And so all of the forces go mostly to this main spar here. These little blocks here were used as alignment aids because the top plate and the bottom plate are not exactly parallel. The top plate is angled up a little bit. And so because of that, I made these little blocks to use as construction aids to make sure everything was built properly and stayed in that orientation while it was being glued. These blocks will be getting removed, and what's going to happen is there's going to be wood strips that go along the bottom and the top here, and also along the edge where the spar joins the outer rib here. You've got like a 90-degree joint here, so there'll be a wood block in there that's epoxied on both sides, and that will really tie everything together much better with the epoxy and make it super durable and stiff. So what else? We're talking about the ribs here. These are the forward ribs. You can see that there's 3 of them here, and they're spaced out. There's little spacers in there. Spacers are the same thickness as these aluminum plates. So when this is all put together, then these aluminum plates will slide in here and get bolted in to this forward rib. And these are what mounts the wing. So that's how that all works. There's the forward ribs, the forward ribs. These are the rear ribs. These are the brackets for the forward ribs, forward part of the wing, and these are the brackets for the rearward part of the wing. And that's how that'll work. Now they're a little ratty ass looking. So what I'll do is, just before I mount them in there, I'll take them to my buffer and buff them all up so they look nice and shiny like that. Make it look a little bit better. A little there. So what's going to happen here now is this is glued now initially with some CA, cyanoacrylate super glue. Just to get it all set up and glue it initially first of all. And then once I'm happy with that, I'll take it out and I'll further glue it with the epoxy and the strips and everything else. It'll tie it together a lot stronger. I talked about the initial setup of aluminum wing compared to a wooden wing. I don't need much for setup on a wooden wing. All I need is a nice flat table and a couple of blocks to block up these ribs, some weights to hold it all down, straight edge. The thing that's nice is when we built these tables, the tables were built to be less than 10/1000ths of an inch from flat. So all I do is I can take my little level here, stick it on the table and set it to 0.0, and then I stick it on my level back here and it should read 0.0 when everything is set properly. And on the spar it should read 0.0, and on the leading edge here it should read 0.0. That tells me that the leading edge and the spar and the trailing edge are all in perfect alignment. Nothing is twisted out of shape. So when everything's 0.0, everything's epoxied in. This won't be epoxied in until later on, but the ribs will all be epoxied in. And then some foam blocks will go in here. And then I'll take my hot wire and it'll run across, and I run the hot wire through it, and that will cut the foam to be exactly the same profile as the ribs. And then it'll get all glued in. Once I'm happy with that, I'll take the leading edge and finally glue it in, epoxy it to the outer rib here and to the edge of the foam. And the same with the trailing edge, it'll all get cut and then the trailing edge will get epoxied in. After that happens, there'll be like an end plate like this that goes on. So it's the full shape of the airfoil. This one is cut out for the leading edge, just a round 1-inch dowel. So this one will get epoxied into here. And if you notice, it's got 6 holes in it here. So there will be these 6 little screws, little Allen screws. That's what will mount the spill plate to the edge, the surface on this end plate. They'll go through these holes, they'll mount the aluminum spill plate onto here. And then what will happen is there'll be like a blind nut like this on the back side, be pressed in, and it'll be captive between the end plate and the outer rib here, so it can't fall out or move out or anything like that. This will get epoxied to this outer rib. So when that happens, it'll tie further again, tie everything together here, like this leading edge and the trailing edge, and we'll just have one surface here that's the end plate. Once I'm happy with all that, then I'm going to skin the wing with a very thin wood veneer. That'll further stiffen it up and give it a little bit of surface strength. And then when that's all done, after that, it'll get covered with a layer of 6-ounce glass and a layer of 2.5 ounce, and then a final layer of 3/4 ounce glass. And a little bit of sanding and some primer and paint, and the wing will be basically done at that point. And just a matter of mounting it on the car and bolting on the end plates. The end plates, like you saw in the drawing, they're quite large. The spill plates, I mean, they're quite large. And then I showed you in the drawing that this handle will get mounted to the spill plate, and it'll get mounted to that 10-degree angle. So Once again, it makes it really easy for me just to put my little level on there, and I can measure 10 degrees, 12 degrees, whatever I want. So that'll help. One of the reasons for the handle is these cars are a little difficult to get in and out of. It's a funny car frame, it's all tubing frame, and a funny car, the whole body tilts up. So the driver, you just tilt the body up, the driver gets in the car and gets out of the car. With these, you've got a real tiny little body that just sort of covers the main cockpit part of the car, and it doesn't work very well to have the body lift up because you've got the wing there. On a funny car, you've got the whole body and the wing at the back of the body. On these cars, you've got the wing, so the wing usually restricts how much the body can come up, makes it difficult. So the easiest way of doing it, or the easier way, is you have to climb into the car. So you step on the wheel, one foot, and you step on the top of the tire with your other foot, because the tires stick out of the body by about a good 6 inches or more. And then grab the handle and step over and step into the car on the seat bar. And then from there, you just drop yourself down into the car, and then never reverse when you get out of the car. So the handle will make it easier, much easier to get in and out of the car. And it'll give me a good reference point to set the angle on the wing. So that's how that all works. And that's pretty much it. So now I'm just going to go ahead and keep plugging away at this. I'll take some more pictures and maybe some video as I go along and update you on the progress. So thanks for watching.